Hello everyone, in this video we're going to learn about the sine, cosine, and tangent. Alright, in the last video we're going to learn the trick how to calculate the sine, cosine, and tangent in the right triangle. Alright, so today we're going to apply those tricks into the unit circle. So now I need to calculate sine, cosine, and tangent of the angle theta created from the initial rate right here and the terminal rate right here. Alright. Now I'm gonna apply the trigonometry in the right triangle OP. I call this K. Alright. So sine equals opposites over hypotenuse, right? You have a trick right here for you to memorize, right? This is what you learned in the last video. Alright, so if you want to review our concepts, please check out the videos in the description below. Alright, so in this right triangle, I have sine equals opposites over hypotenuse. Opposites, which means y value, right? Hypotenuse, which means this guy right here, right? The distance from point P and the origin, this is the radius of the circle, right? So the radius of the circle is r, right? So sine equals y over r. Now in the unit circles, r equals 1, right? We're gonna learn about the unit circle in the next lesson, right? Now, what if I need to calculate cosine? So cosine equals adjacent over hypotenuse, right? Adjacent is this guy right here, right? So this guy equals this guy right here. So it could be S, right? Hypotenuse still R, right? So S over R. We get this one right here. Now tangent equals opposites over adjacent, right? So tangent opposites is going to be y, adjacent is going to be s, right? So tangent of theta is going to be y over s. Or you can use the formula tangent equals sine divided by cosine, which is we learned in the last video, right? Now there is a trick that I think is really helpful for you to learn in this unit, right? So you have the x and y coordinate right here, and you have the first quadrant and the second quadrant, the third quadrant, and the fourth quadrant. Alright, and the unit circle in the middle right here, right? So we need to memorize the sentence. All students take calculus, okay? Going counterclockwise, right? So all on the first quadrant. Student, you're going to put it on the second quadrant. Tech, you're going to put it on the third quadrant. And calculus, you're going to put it on the fourth quadrant, okay? So, R, which means R, sine, cosine, and tangent. Alright, so if I point P on the first quadrant, sine, cosine, and tangent always positive, right? Now, if the point P on the second quadrant and letter S right here stand for sine, right? So only sine is positive, the rest one are negative, right? Next one, if point P on the third quadrant, alright, and we use the letter T right here, which means tangent. Only tangent positive. The rest one should be negative. Now, if the point P is on the fourth quadrant, alright, we have calculus, right? The letter C right here stands for cosine, right? So only cosine positive. The rest one should be negative, right? So keep in mind, the y-axis represents the sine function. The x-axis represents the cosine function. Now let's take a look at the first example, right? The figure shows a circle center at the origin with an angle of measure theta in standard position. Alright. The terminal rate of the angle intersects the circle at the point P. The coordinates of point P are S and Y. Which of the following is true about the cosine of theta, right? So we just use the trigonometry in the right triangle, right? So we have the angle theta right here. We draw an arrow. This guy becomes opposite, right? And then this guy becomes adjacent, right? And this guy becomes the hypotenuse, right? Alright, so cosine equals adjacent over hypotenuse, right? Adjacent, which means this is the S value, right? Opposite, which means the Y value, right? Hypotenuse, which means the radius, right? Now the radius is 3. Look at this point right here. 3, 0, right? So the distance from here to here is going to be 3 units, right? So it's the same thing as distance from here to here is going to be 3 units, right? So the radius is 3, right? Now, cosine equals adjacent over hypotenuse, right? So cosine of angle theta equals adjacent. Adjacent is going to be the distance from here to here only, okay? Right? So distance from here to here is the same thing as distance from here to here, right? It's going to be S value over hypotenuse. Hypotenuse is distance from here to here, right? It's going to be radius, right? But radius equals 3, so it will be S over 3. So the answer is A, right? Now let's move on to the example number 2. The figure shows a circle with radius phi centered at the origin with an angle of measures theta in standard position. The terminal rate of the angle intersects the circle at point P. Find the following values: sine, cosine, and tangent theta, right? So observe that on the circle right here, point P and this guy right here reflected over the x-axis, right? So because 2 points reflected over the x-axis, they have the same s value and y value should be opposites, right? So this guy turns out to be 3, -4, right? Alright, so now we learned in the last lesson about the reference angle, right? So this angle theta from the initial rate right here and then terminal rate right here. So it's going to be this guy right here, right? So we cannot create a right triangle using this angle theta right here. So we have to use the reference angle, right? The reference angles of the angle theta right here, which means this guy right here, right? So make sure you review the last video that's posted in the description below, right? So sine theta, so I'm going to apply the trigonometry in the right triangle over here, right? The radius right here equals phi, right? It's going to be right here. So radius is phi. Now, the s value is going to be from here to here right here, right? S value is 3. The y value right here is going to be -4, right? So, sine theta, we use this one right here, opposite over hypotenuse, right? So, draw the arrow opposite, which means -4, right? Hypotenuse, which means phi right here. Now, cosine is going to be adjacent over hypotenuse, right? Adjacent, which means 3. So, it could be 3 over hypotenuse, which means phi, right? Now, tangent theta is going to be opposite over adjacent, right? Opposite, which means -4. Adjacent, which means 3. So it should be -4 over 3. Now let's move on to example number 3. The figure shows a circle with the radius centered at the origin with an angle of measure theta in standard position. the terminal rate of the angle intersect the circle at point P, right? So this terminal rate. This is initial rate. Alright. The coordinate of point P are S and Y, right? The point Q, R, and S are the result of reflecting the point P across the y-axis, the origin, and the s-axis respectively, right? Now, example number 3. Find the coordinates of the point Q, R, S in terms of S and Y. Alright, so point Q right here is the reflection point of point P over the y-axis, right? So which means y stay the same, the s value opposites, right? So we have negative s comma y, right? Now point R is the reflection point of point P over the origin, right? So s and y should be opposites, right? So it could be negative s comma negative y, right? Now, point S is the reflection point of point P over the x-axis, right? So, S should stay the same, y opposites, right? So, it's going to be S, comma, negative y, right? Now, example number 4. Find the sine of the angle whose terminal rate intersect the circle at the point S, right? So, this is terminal rate. Right? And this is the initial rate, right? So the angle should be this guy right here, right? And then we need to use the reference angle, right? Because we cannot create a right triangle using this angle, right? So the reference angle should be this one right here, right? Now, this guy becomes opposite, right? This guy becomes adjacent, and this guy becomes hypotenuse, right? Alright, but hypotenuse is going to be the radius right here, right? So sine theta equals opposite over hypotenuse. Opposite, which means the distance from here to here, right? But distance from here to here is going to be negative y right here, right? So negative y over the radius, which means over r, right? Okay, example number 5. Find the cosine of the angle whose terminal rate intersect the circle at point Q. Alright, so terminal rate is right here, right? And initial rate right here, right? And this is the angle theta, right? Now, we cannot use this angle, right? We need to use reference angle. So the reference angle is right here. Alright, so we draw an arrow. This guy becomes opposite, right? This guy becomes hypotenuse, right? Because this guy opposite to the right angle, right? And this guy becomes adjacent, right? So cosine of theta is gonna be adjacent over hypotenuse, right? Which means the s-coordinate of point Q, right? So point Q, the s-coordinate is gonna be negative s. Right here, right? Over all. Now, example number 6. Find the tangent of the angle whose terminal rate intersect the circle at point R. Alright, so point R right here, right? And then the angle is going to be this one, right? Because the initial rate is going to be right here, and terminal rate is going to be right here. So we cannot use this angle to create the right triangle, right? So we need to use the reference angles, right? So the reference angle is going to be right here. Alright, so the right triangle should be right here. Right, so this right angle, right? So we draw the arrow, right? This guy becomes opposite, this guy becomes adjacent, and this guy becomes hypotenuse, right? Now we need to calculate the tangent, right? Tangent equal opposite over adjacent, right? So it's going to be tangent theta. It's going to be opposite, which means the s-coordinate of point R, right? The y-coordinate of point R, right? Which means this one right here, y-coordinate, right? The y-coordinate of point R is going to be negative y right here, right? So negative y over adjacent, which means the x coordinate of point R, right? So x coordinate of point R, which means negative s right here, it's gonna be over negative s. Now simplify, it's gonna be y over s. Now let's move on to the next example. Example number 7. Let theta be an angle in standard position whose terminal rate coincide with the line y equals negative 3s in quadrant 2. Alright, so first you need to sketch the line y equals negative 3s, right? Now you have initial rate, it's gonna be this one, right? Always, right? Now the second quadrant is gonna be right here, right? So terminal rate is gonna be something like this, right? So I call this a point P, and I call this a point Q, right? And this is actually the line y equals negative 3s, right? Now the angle theta is gonna be this one, right? Alright, so we need to find sine theta, right? So we cannot use this angle to create the right triangle, right? So we need to use the reference angle. So the reference angle is gonna be right here, right? So we need to create the right triangle. Alright, so we draw the arrow. This guy becomes opposite, this guy becomes adjacent, and this guy becomes hypotenuse, right? Alright, so sine theta is going to be opposite over hypotenuse, right? Now, we don't have the radius. Now, suppose point Q has the coordinate x and y, right? So does that mean the distance from here to here is going to be the y value, right? The distance from here to the origin right here, this is the s value, right? Now let's apply the Pythagorean theorem in the right triangle right here. So we have s squared plus y squared equals r squared, right? Now we write s squared, y equals negative 3s right here, right? So y squared is going to be negative 3s altogether squared. Don't forget parentheses, equals radius squared, right? Now it turns out to be s squared plus 9s squared equals radius squared, right? Now s squared plus 9s squared is going to be 10s squared equals radius squared, right? So s squared equals radius squared divided by 10, right? And then you're gonna take square root both sides, so s equals plus and minus r over square root of 10, right? You can radicalize this one by multiplying the top and bottom by root 10. Alright, so this guy turns out to be plus and minus r root 10 over 10, right? Now observe that the radius always positive, right? Now because the points stay on the second quadrant, right? Which means the y value is positive and the s value should be negative, right? So because s value is negative, then s should be negative r root 10 over 10. Sine theta equals opposites over hypotenuse. Opposites, which means the y right here, right? So it could be y over hypotenuse, which means r, right? So y over r. But y equals negative 3s, right? So we substitute negative 3s for y, right? Negative 3s over r, right? Now s equals this one, right? So we substitute this one over here, right? So we have negative 3 times negative side right here. It's going to be positive 3, right? So it should be 3r root 10 over 10 over r, right? So this one can be written as 3r root 10 over r times 10, right? Now we're going to simplify r and r. So the answer must be 3 root 10 over 10, right? Now we need to calculate cosine theta, right? Cosine theta is going to be adjacent over hypotenuse, right? Adjacent, which means s value, right? Hypotenuse, which means radius, right? So it could be s over r, right? So it's going to be negative r root 10 over 10 divided by r, which means we put r right here, right? So r right here cancel out. The answer is negative root 10 over 10, right? Now tangent theta is going to be opposite over adjacent, right? Opposite, which means y, adjacent, which means s, and this is actually the slope of the line right here, right? So it's going to be equals negative 3. Now we can verify this one by using the formula right here. Opposite over adjacent. Opposite, which means y, right? So I have y over adjacent, which means s, right? So it's going to be y equals negative 3s, so I put negative 3s right here over s, right? So s and s cancel out. The answer is negative 3, which is right. Now let's move on to the next example. Alright, so in this example, make sure you check your work using the trick right here. All students take calculus, which means if the point on the first quadrant, sine, cosine, tangent is going to be positive. If the point on the second quadrant, sine positive, cosine, tangent is going to be negative. If the point on the third quadrant, tangent is positive, cosine, sine negative. And if the point on the fourth quadrant, cosine positive, sine tangent negative, right? So example number 1 right here. The point stay on the first quadrant, right? So the angle theta right here, right? So we're gonna get the right triangle, right? So we have the right angle right here, right? So the angle theta right here, this guy becomes opposite, right? This guy becomes adjacent. And then this guy always hypotenuse, right? The one opposite to the right angle is hypotenuse, and this is actually the radius of the circle, right? So the radius of the circle is 12 given right here. Right, so sine theta is going to be opposite over hypotenuse, right? So opposite, which means the y value of this point right here, right? So this is the y value, and this is the s value, right? Opposite, which means y value is going to be 11.644 divided by hypotenuse, which means 12, right? So we're going to print up the calculator. So we have 11.644 divided by 12, right? So it's going to be 0.9703, right? 0.9703. Now cosine theta is going to be adjacent over hypotenuse. Adjacent, which means s, right? So it can be 2.9 over 12, right? So it's going to be 2.9 divided by 12. So it's going to be 0.2417, right? So approximately 0.2147. Now tangent is going to be opposite over adjacent, right? So opposite is going to be y value. So it's going to be 11.644 divided by adjacent. It could be 2.9, right? So it's going to be 4.0152, right? So 4.0152. Now make sure you check your work, right? So because the point on the first quadrant, all sine, cosine, and tangent positive, right? So this is right here. Now the point stay on the third quadrant, right? So if you calculate it, only tangent positive, sine, cosine should be negative, right? Now We have the angle right here, but we cannot use this angle, right? We need to use the reference angle. So the reference angle is right here. So keep that in mind, right? So we draw the right triangle, right? And then this guy becomes opposite. This guy becomes adjacent, right? The one opposite to the right angle is hypotenuse, right? Hypotenuse is the radius. The radius is phi right here. So keep that in mind. So sine theta is going to be opposite over hypotenuse. Opposite, which means the y value of this point right here. So it can be -2 over hypotenuse. Hypotenuse is phi, right? So it could be -2 over 5. Now cosine theta is going to be adjacent over hypotenuse. Adjacent right here, which means the s value of this point, right? So it's going to be -4.58 over hypotenuse, which means 5, right? Now we can calculate this one. So it's going to be -4.58 divided by 5. Alright, so it's going to be -0.916, right? So it could be -0.916. And the answer for this one is going to be -0.4, right? Now, tangent theta is going to be opposite over adjacent, right? So opposite, which means the y value is going to be -2 over adjacent. It's going to be -4.58, right? Negative and negative cancel out, right? So we have 2 divided by 4.58. It's going to be 0.4367, right? So 0.4367. Alright, now we check our answer, right? Only tangent positive, good. Sine, cosine, negative, good, right? So this. Now let's move on to the last example. Alright, so the points stay on the 4th quadrant, right? So the angle is going to be this one right here, right? And again, we cannot use this angle, right? We need to use reference angle, which is the one right here, right? So we draw the right triangle, right? So we project this one down, right? So the right angle is going to be right here. This is the right angle. Alright, so this guy becomes hypotenuse, right? The angle right here. So the opposite is going to be this one, right? The adjacent is going to be this one, right? So the opposite, which means the y value, right? This is y. And this guy adjacent, which means the s value, right? Now this is s and this is y. The radius is 2, right? Radius is 2. Alright, so sine theta is going to be opposite over hypotenuse. Opposite is going to be y value. Y values is -0.5, right? So -0.5 over hypotenuse is going to be 2, right? So 2. And then -0.5 divided by 2 is going to be -0.25, right? Cosine theta is going to be adjacent over hypotenuse. Adjacent, which means the s value, right? S value is going to be 1.937. So 1.937 over hypotenuse, which means 2, right? So we have 1.937 divided by 2. So it's going to be 0.9685, right? Now, tangent theta is going to be opposite over adjacent, right? Opposite, which means y value. Y value is -0.5 over adjacent. Adjacent, which means s value is going to be 1.937, right? So this guy turns out to be -0.5 divided by 1.937. So the answer is -0.2581, right? Alright, so now we check our work, right? The points stay on the 4th quadrant, only cosine positive, right? The rest one should be negative, cosine positive, good. This guy negative good, this guy negative good. Alright, now the last one. The point stay on the second quadrant, right? Now, again, we cannot use the obtuse angle right here, right? We need to use the reference angle, so it's going to be right here, right? So we need to make the right triangle. It's going to be right here. Alright, so the angle right here, this guy becomes opposite, this guy becomes adjacent, right? The one opposite to the right angle is hypotenuse. Hypotenuse is the radius. The radius is phi right here, right? So radius is phi. So hypotenuse, which means radius, adjacent, which means the s value of this point, right? S value is going to be negative 1.96, and the y value is the opposite right here, right? The y value is going to be 4.6 right here, right? So sine theta is going to be opposite over hypotenuse. Opposite, which means y over hypotenuse, which means radius, right? So y is going to be 4.6 divided by 5, right? So 4.6 divided by 5. So the answer is 0.92, right? Now cosine theta is going to be adjacent over hypotenuse, right? Adjacent, which means s value. S value is going to be negative 1.96 divided by 5, right? So negative 1.96 divided by 5. So the answer is negative 0.39, right? Negative 0.392, right? Now tangent theta is going to be opposite over adjacent, which means y over s, right? So y value is going to be 4.6 over negative 1.96. So the answer is 4.6 divided by negative 1.96. So it's going to be negative 2.347, right? Negative 2.347. Now we'll use the trick right here. We need to check our answer, right? So because the point stay on the second quadrant, so it's going to be right here, only side positive, and then the rest one should be negative, right? Side is positive, good. This is negative, negative, good. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.